Good evening, everyone. Welcome to HESI's Environmental Epidemiology Committee webinar series. I'm Sandrine Degline. I'm a scientific program manager with HESI, and I also co-manage the Environmental Epidemiology Committee. And with me are two of our co-chairs, Dr. David Miller with the US EPA and Dr. Igor Borstin with Drexel University. So today's webinar will be given by Dr. Tim Lash with Emory and Dr. Brian Nosek with the Center for Open Science. And the focus on the webinar will be transparency and data sharing. But before we start, I would like to provide you with a little bit of background on what the Environmental Epidemiology Committee is doing and one of the latest projects we've been working on. So for those of you who do not know, the mission of the committee is to engage stakeholders from various sectors and fields of expertise in the development of a strategy to increase the use of epidemiological data in risk assessment and regulatory decision making. And one of our latest projects was the creation of a web platform, which we called Epifora, or Epidemiology for Risk Assessment. And if you visit this platform, you'll see that it compiles information that's relevant to the field of epidemiology and risk assessment. And more importantly, it hosts publicly accessible database of stakeholders who are interested in strengthening the use of environmental epidemiology in human health risk assessment and decision making. So if you are interested in that field and you are not only an epidemiologist or risk assessor, but also an exposure scientist or statistician or toxicologist, or just if you're just generally interested in the field, you can create a profile in that database. And the goal of this database is to help with communication and collaboration among professionals in the field. We also encourage students to join that database because ultimately, once the database is well populated, this could be an opportunity to find internships or mentorship and to build a strong community of practice. So you can check it out. You've got the website here. I encourage you to visit it and create a profile if you're interested. So a few housekeeping details for today's webinar. Today's webinar is recorded and we will post it on our webpage in a few days. So you can visit the committee webpage on the HESI website. If you would like to ask questions, which we encourage you to do, you can use the question box. So you can see it circled in red on the right. And your questions will be read at the end. So both of our speakers will give their presentation and we will read them your questions at the very end. Now, if you have any questions about the committee or about this particular project, feel free to contact me. You've got my email address. And if you would like some information about future webinars, you can check the HESI website and our committee page. We also post on social media. And if you subscribe to the HESI newsletter, you will read about it there too. So a disclaimer before we start to let you know that the views expressed by the speakers are those of the speakers only and do not necessarily reflect the views of HESI or the committee or their members. So now I'm going to give the floor to Dr. David Miller, one of our co-chairs, who is going to introduce the speakers.
Great, thank you, Sandrine. I'll give Dr. Lash is going to be talking first on reproducibility in epidemiologic research, history, hysteria, or hypothesis testing. Dr. Brian Nosek will talk second, basically. His title is Culture Change Toward More Open, Rigorous, and Reproducible Research. I'll just introduce Dr. Lash at the moment here and Dr. Nosek when he begins. Dr. Lash is the O. Wayne Rollins Distinguished Professor of Epidemiology and Chair of the Department of Epidemiology at Emory University Rollins School of Public Health. The research focuses on predictive and prognostic markers of breast, prostate, and colorectal cancer recurrence. Dr. Lash's methodological interest focuses on developing and implementing methods to quantify the influence of systematic errors on epidemiologic research. Funding from the National Library of Medicine supports his work to develop methods that quantify the influence of systematic errors on the reproducibility of epidemiologic study. He is editor-in-chief of Epidemiology, a leading general interest epidemiology journal, and co-author of 2 epidemiology textbooks, Applying Quantitative Bias Analysis to Epidemiologic Research, 2nd edition, and Modern Epidemiology, 4th edition. So thank you very much. Turn it over to Dr. Lash. Thank you.
Thanks very much. Pleasure to be here. Let me see if I can get my screen sharing right. There we are. Can someone just tell me if they're seeing just the slideshow?
Yes.
Great. Thank you. And it is a pleasure to be here and to have the opportunity to exchange these ideas with Dr. Nosek. I want to start with just some basic presumptions or ideas of mine. Trying to get the screen so I can see. So I'm presuming all of us here have a benign and sincere interest in reproducibility and replication and improving reproducibility and replication. I do think, and maybe during the Q&A we can talk a little bit about that there is potential for malfeasance and malintent, and that is unfortunate, but something that can't be ignored. My views kind of broadly are that I admire the idea of pre-registration and open data. It's certainly hard to be against some of these ideas. And I admire those who endeavor to persuade others to pre-register or to make research data publicly available. I think these are good things. At the same time, I don't expect all protocols to be pre-registered or all research data to be required to be publicly available. And I don't think anybody should be shamed if they cannot or don't want to pre-register protocols or make research data publicly available. So I think there's an important distinction between what we advocate and what we require. So with that as sort of foundational views, my outline is just a very brief problem statement about the reproducibility crisis, and then a 3-part presentation. The first part is my view that to the extent that we are suffering a reproducibility crisis, it emanates primarily from the culture of null hypothesis significance testing, that the proposed remedy of compulsory pre-registration is likely to be ineffective, and that there's in fact evidence from the clinical trial literature showing that. And third, I think it's important to remember the history of what I'll call false positive alarmism in epidemiologic research, which is not really proved out over the long-term view. So, as you all know, there has been a view in the last years especially, re-emergence of concern about the reproducibility of scientific results. You'll see this in the lay literature. For example, this article in The Economist in 2013. Scientists like to think science is self-correcting, but to an alarming degree it's not. And a survey of scientists published in Nature 2016, where only 3% said that they didn't think there was a reproducibility crisis. More than half said they thought there was a significant crisis, and 38% said there was a slight crisis, which someone needs to do a little training on survey research just to ask that kind of slight crisis. So in my view, this primarily emanates from the culture of null hypothesis significance testing. And so long as we select results for attention by null hypothesis significance testing, we are going to have poor reproducibility. And that's because of this important link to innovation, which has also over the last 40 or so years grown in prominence in scientific research. For example, the terms innovative, groundbreaking, novel, the prevalence of those in abstracts in PubMed grew 25-fold over the 40-year period, 1974 to 2014. And the authors of this study say that really we have to conclude that that comes from a response to increasing pressure for novelty in scientific research. And that's important because if we practice in a culture that relies on null hypothesis significance testing to identify results for emphasis, there is an undeniable mathematical link between innovation and reproducibility. And that is that the positive predictive value will be poor because it depends on the prevalence of true truly non-null hypotheses in the research enterprise. So here's a simple depiction of that, where we have a research enterprise where there's going to be 10,000 hypotheses evaluated. 1% of them are truly non-null, which is the proportion that I chose to illustrate what we might call an innovative research enterprise. And so if the power of this enterprise is 80%, then we'll find 80 of those 100 to be statistically significant. And we'll find with a type 1 error rate of 5% of the 9,900 that are null to be false positives. And that means that the positive predictive value of a statistically significant result will be only 14%. And that's the reproducibility crisis right there. I mean, that is exactly what we are talking about when we say that results are not self-correcting, that they don't prove out. Now we could change the prevalence of truly non-null hypotheses here. I've changed it to 50%, still with 80% power and type 1 error rate of 5%. Now the positive predictive value is much better, it's 94%. So if you want null hypothesis significance testing and reproducibility, the best way to do that is to study what's already well known, but that's not innovative, and that's really not the point of science. Now, sometimes people say that instead of a testing mindset, we should have an estimation mindset, and I fully agree with that. But what we have found is that the estimation comes with what we call closet significance testing. That is, does the 95% confidence interval also become evaluated as to whether or not includes the null hypothesis? And in that case, we have a second problem with what appears to be poor reproducibility. So here's a kind of conventional depiction of null hypothesis significance testing, where we have the null distribution depicted in blue, and then the alternative true distribution depicted in the red dashed line, and the black vertical line is the testing threshold. And so if we have an acceptable type 1 error rate of alpha 0.05, half of that is the area under the curve to the right of the testing threshold. And if we have a type 2 acceptable error rate, beta equal to 0.2, that's the area under the red curve to the left of the testing threshold. And the power is 1 minus that beta, or here it's 80%. Now, if we only pay attention to results that are selected from that red dashed line, if they are statistically significant, or in other words, to the right of the black vertical line, most of those are going to be overestimates, because we have the entire distribution to the right of the mode available for selection as statistically significant, but only the compressed area to the left of the mode between that, the mode and the testing threshold, that are underestimates. This is just, again, math. This is the way the enterprise works. And the consequence is that when you have estimation plus testing, that leads to overestimations of the effects, unless the power is 100%, which is seldom the case. And in fact, you see this in the reproducibility literature. Here's a figure that I have borrowed with permission from the Science 2015 paper, on which Dr. Nosek was an author. And we see on the x-axis the original estimate, and on the y-axis the replication effect estimate, and the ascending diagonal is the line of identity. And what we see is that most of the replication results fall below the diagonal line. That is exactly the regression to the mean that is expected, because of the fact that the initial estimate is selected by statistical significance and is therefore likely to be an overestimate. Now, we can call this a reproducibility crisis, but if it's a crisis of our own making. The data, the results are behaving exactly as expected. But this turns into the perception of poor reproducibility, and I have several examples like this. You can read more in the 2022 editorial in Epidemiology. Here we have a study of the association between subcutaneous heparin and its effect to reduce the risk of deep vein thrombosis compared with intravenous heparin. And we have one result that is statistically significant, shown in the red dashed line. It's the odds ratio of 0.62 with an interval excludes the null. We have a second result, which is almost exactly the same point estimate, 0.61 instead of 0.62, but measured with less precision, not statistically significant, and these were interpreted as showing different effects. In other words, as the second analysis did not replicate the first analysis. Just wrong. It is exactly the same estimate. So what could we do instead? Well, what if we discarded the culture of null hypothesis significance testing in favor of estimation and without evaluating whether or not the estimate's interval included the null? What would happen? Well, here's a depiction of the scientific method that appeared in a paper titled A Manifesto for Reproducible Science. We generate a hypothesis, design the study, collect the data, analyze and interpret, and then conduct the next experiment. And the authors then said that where we go wrong, shown here in red, is all these misapplications of this scientific method. All of those that I've circled here in blue would disappear if we actually discarded the culture of null hypothesis significance testing. Two of them I'll look at in more detail, p-hacking and harking. So p-hacking is the process of analyzing data until you find a statistically significant result. So we analyze the data. If the results are significant, we stop and report them. If not, we do one of the long lists on the right and circle back to analyze the data again until we find something that's statistically significant. This is clearly a misapplication of the scientific method. If we got rid of significance testing, we just analyze the data and report the results. All of the misappropriation on the right stops. Harking is hypothesizing after the results are known. And so here's an example where we have jelly beans causing acne as the hypothesis. Scientists investigate. They find a null association between jelly beans and acne. But the investigators go on. They look at purple jelly beans, brown, pink, tan, cyan, until finally they look at green jelly beans and they find a statistically significant result. And that leads to the news report that green jelly beans are linked to acne. This is hypothesizing after the results are known until we find a statistically significant result. But imagine what happens if we just get rid of all of these significance tests. Then this result disappears, the news report disappears, and we're left with just the important finding that jelly beans do not cause acne. It is the harking emanates directly from the search for a statistically significant result. So summarizing part one, the cultural norm of selecting results for attention by null hypothesis significance testing is, in my view, the root of poor reproducibility. And it's been seen in the literature on the reproducibility crisis. Innovation, reproducibility, and null hypothesis significance testing cannot coexist. That, in my view, is just a mathematical fact. The culture of null hypothesis significance testing has built a machine to overestimate effects, and we see that in the literature. Replacing null hypothesis significance testing with estimation is likely to be the most effective way to improve reproducibility of scientific results, but has been seldom suggested for that purpose. So what has been proposed? Well, added regimentation of research practices has been the main proposed solutions for improving reproducibility. One of those has come from the guidelines for transparency and openness promotion, the top guidelines. And one of the main focuses has been pre-registration of studies, compulsory pre-registration of studies and analysis plans. despite the fact that those proposing it have in fact admitted that there's not sufficient experimental evidence establishing it for improving reproducibility. And that harkens back to the 2019 industry consortium, which also proposed compulsory pre-registration of observational epidemiology studies, and also said that there was not evidence that that would improve reproducibility. And I point this out because if this were a medical intervention or a public health intervention, it's inconceivable to me that we would propose an intervention of this size and at the same time acknowledge that there's not evidence that it will be effective. There is actually evidence from the clinical trial experience that it's not effective. So clinical trials have, for more than 15 years, have been required to be pre-registered. And the reason was that there should be a database of all trials so that participants would not be randomized to interventions that had already been shown to be ineffective. That would be unethical. Secondary objectives were to improve compliance with protocols, adherence to protocols. That secondary objective has not been attained. The first objective has been attained, and that was the ethical imperative. With regard to the secondary objectives, here's just a few reviews. A review of the 6 highest impact medical journals. 1/3 of the trials were out of compliance. 10% registered after primary endpoint ascertainment could already have taken place. In the second review, less than half of the trials were registered. And in the half that were in compliance, 1/3 showed evidence of discrepancies favoring selection of results that were statistically significant, going back to the first part of my presentation. And in this huge undertaking by Cochrane Consortium, a meta review of 16 reviews, each of those 16 reviews, median of 54 trials in the review, discrepancies between protocols and trial reports were described as common. So the idea that compulsory pre-registration of protocols is going to improve adherence to reproducibility, improve adherence to pre-registered protocols, just doesn't pan out when you look at the substantial evidence from the trials literature. The second part of the regimentation that's been proposed has to do with access to open data. And I have some concerns also with mandatory open data requirements. First, it's often impossible in epidemiologic research to share data. Second, it's really difficult for journals, especially journals of the size of the journal for which I am editor-in-chief, to police the data availability. And third, I think the demand for use of open data might not match the expectations. And again, there's evidence from the trial literature to support that. So first, data are difficult or impossible to share. Here's my bibliography. It's a little bit out of date, but first paper I published was in 1998, and this is through 2019. Now, if we subtract the papers where we were using data collected with informed consent from participants, in which they were promised that the data would not be shared, these are the papers that would disappear. Many of the papers early in my career used data sets that collected data with informed consent, and those data could not be shared. If we subtract the data that were collected by use of a data use agreement, in which the data use agreement promised that I would not share the data, additional papers would disappear. If I subtract the papers that made use of public US data sets, which require each investigator to obtain their own permission to use the data, so again, they cannot be shared by the investigator, further papers disappear. And then I've been fortunate to have a long-standing collaboration with the Danes, yielding many of the papers that I've published. None of those allow me to share the data. So what's left is just a few papers that would have had used data Many of these are the seldom read Tim Lash methods papers that are actually not using research data at all. Can journals enforce requirements of open data? Epidemiology, the journal for which I'm editor, has been asking authors to explain how readers could obtain the data or the computing code for a long time. And we looked at the first 475 submissions after we started asking, and 16% of those papers, the authors replied that the data were publicly available. 23% said contact the author to obtain the access. 19% said they were available through some other process. Only 20% said the data were not available. It would be a huge undertaking for the journal to confirm that for the 58% of papers where authors said the data were available by some of these methods, that in fact the data could be obtained. That would be, we simply do not have the resources to do that. Finally, on this part, I think the demand for the use of open data may exceed expectation, may not match the expectations. And again, this has been studied in the trials literature. A consortium of providing data from more than 500 cardiometabolic trials in multi-sponsor data sharing platform. Only 15% of those trials, 29% of the phase 3 and 4 trials, had the data even been accessed by someone. And a negligible minority of the analyses have reached publication. So the idea that making data publicly available is going to result in a huge replication effort just doesn't match the trial's experience. So summarizing the second part of my presentation, the perceived reproducibility crisis has been met with calls for regimentation, and foremost among these has been compulsory registration of protocols and compulsory open data. There's little evidence to suggest these would improve reproducibility, and there's substantial evidence from the trial's experience that they will not. Finally, you know, I'm getting old. I've been seeing this kind of thing for some time. There is a history of what some call the false positive alarmism in epidemiology. I did a PubMed search of the papers that included the phrase reproducibility of results, which first appeared even before, you know, in the early 1980s. One of the early ones in epidemiology is a paper by Mays and Feinstein et al. In 1988, a collection of 56 topics with contradictory results in case control research. In other words, poorly reproduced studies. Among those 56 were the idea that smoking causes cervical cancer, that estrogen replacement causes breast cancer, that radiation therapy causes leukemia. All of these are now, I think, well-established causal associations. Many of us know the Taub's 1995 paper, Epidemiology Faces Its Limits. I'll come back to that in a minute. Ioannidis, the 2005 paper, Why Most Published Research Findings Are False. Buffett et al., 2008, False Positive Results in Cancer Epidemiology. And then the Manufacturers Consortium in 2009. So there's kind of been this consistent, for as long as I've been involved in epidemiology, false positive alarms about the research that we generate. One of the most famous of these was the Taub's 1995 paper, Epidemiology Faces Its Limits, in which Taub said that epidemiology studies yield a mind-numbing array of potential disease-causing agents, yielding an onslaught of constitutionally contradictory results. Poor reproducibility. That paper's been cited more than 1,000 times to cast doubt on epidemiologic research. And in the paper, table 1 is a list of associations that Taub selected because he believed these were silly ideas that epidemiologists were studying. And he gave the challenge, are these dangers real? You be the judge. So we, in 2022, took up the challenge. We published just recently a paper in Science Advances called Epidemiology Beyond Its Limits. This was a crowdsourced project involving more than 35 doctoral students in epidemiology here at Emory. And we looked at these 51 associations selected by Taubes as unlikely to be causal. And for each one, we found a recent meta-analysis, and we looked to see if there had been public health policy recommendations made about it. And what we learned is that a quarter of these associations that were selected by Taubes because he thought they were silly ideas, 1/4 of them now are established as causal, and there are public health recommendations addressing them. Among these are the idea that alcohol causes breast cancer, residential radon exposure causes lung cancer, and use of tanning devices causes melanoma. All of these examples where there are public health guidance now. So summarizing part 3, there's a long history of criticizing epidemiology for generating false positive associations. The critical papers receive a lot of attention. There have always been contemporaneous rebuttals. They receive almost no attention. And with just this Taubes exception, there's seldom long-term follow-up to see whether the critique stood the test of time. So wrapping up, it's my view that the perceived reproducibility crisis emanates substantially from the culture of null hypothesis significance testing. The results are behaving exactly as expected. If it's a crisis of our own making. Proposed solutions will increase research regimentation, but if you don't address this root cause, I don't think they're going to yield much benefit. And in fact, the trials literature supports that. Abandoning null hypothesis significance testing is more likely to yield real benefits, but that's not often been proposed. Finally, this idea of epidemiology generating a lot of non-reproducible false positive alarms, it has a long history, but in the one examination of the long-term evidence, false alarms are more likely than false positives. So I'll close there, and I look forward to hearing Dr. Nosek's presentation.
Great, thank you. Thank you very much, Dr. Lash, on that. As we said, we'll go directly to Dr. Nosek. And a reminder to folks that if you have questions, we'll read them at the end. And there's the question box that Sandrine Deglin had pointed out. Feel free to type those in on that. So just a quick intro background on Dr. Nosek while Sandrine is putting up his slides. Dr. Brian Nosek has co-developed the implicit association test, a method that advanced research and public interest in implicit bias. Nosek co-founded 3 nonprofit organizations, Project Implicit to advance research and education about implicit bias, the Society for the Improvement of Psychological Science to improve the research culture in his home discipline, and the Center for Open Science, COS, to improve rigor, transparency, integrity, and reproducibility across research disciplines. Nosek is executive director of COS and a professor at the University of Virginia. Nosek's research and applied interests are to understand why people and systems produce behaviors that are contrary to intentions and values, to develop, implement, and evaluate solutions to align practices with values, and to improve research credibility and cultures to accelerate progress. Dr. Nosek.
Thank you very much for inviting me to this session, and thanks to Dr. Lash for participating in the excellent presentation. What I'd like to start with is acknowledging what is a vast overlap of agreement between Dr. Lash's perspective and comments that he made in his presentation and my own, and including some of the activities of the organization that I represent. But of course, a lot of this kind of meeting is most interesting to try to poke in at where the differences are. So I'm going to try to highlight those initially, and then I'll go to my prepared remarks just by calling out a few of the places of notes as Dr. Lash made his presentation. One in the opening was noting that reproducibility of the opening section on reproducibility challenges is that selection by whether it's statistically significant or not is a huge factor for reproducibility challenges. Now, that is an area of strong agreement for me. And so the only question, I think, of where there might be daylight between our perspectives is the extent to which that is an explanatory factor for reproducibility challenges. I put it, it is the only factor in question mark for Dr. Lash's comments. He can clarify that. I suspect that both of us allow that there's other factors that have influence. Where I would suspect we would end up differing is where our confidence intervals are around our best guess of what proportion of the variance that factor explains. Likewise, a major point of the presentation was that estimation approaches and removal of null hypothesis significance testing would reduce a lot of the reproducibility challenges, particularly because of this selection based on significance. And again, we agree entirely on there, and it may only be on our estimation of how likely that is to address those issues that he noted in the life cycle completely or partially. In the second part on pre-registration with clinical trials as a case example, he highlighted a lot of the very good evidence that is accumulated in the meta-science literature trying to examine pre-registration and the extent to which researchers adhered to or deviated from those pre-registered commitments. And there's a lot of evidence about outcome switching, about retrospective registration and reporting of discrepancies between protocols. And all of that is very strong evidence that pre-registration is not guaranteeing that researchers follow through or document and clarify the variations between their pre-registered design and their ultimate report. The main response that I would have to that is that the only reason that we know about those variations is because of the pre-registration requirement. If every other field may have those exact same things happening, but outside of what is visible and detectable because we don't have any documentation of what was planned versus what was ultimately reported. And while we can continue to improve the overall rigor of research practices, my operating assumption is that by improving transparency of the entire research life cycle, we will provide the opportunities to detect suboptimal practices and provide and promote correctives to those for forward-looking research. In the area on open data, there's also a lot of agreement on the key points Dr. Lash made. So for example, some data is difficult or impossible to share, and that is definitely the case. I have work of my own that I cannot make publicly accessible, the data, even though I have a strong commitment to sharing every bit of data that I can that comes out of my laboratory or research. So any policy that has an open data requirement has to include exceptions for reasonable reasons that one can't share the data. Proprietary, personally identifying information, sensitive data of other kinds. And that policy implementation has to be responsive to those reasons, and editors can make then decisions based on, you know, if I say I can't share it because I don't want to share it, the editor might say, well, that's not really a compelling reason. You still need to meet the requirement. But if I say I can't share it because this has actual health information in it, the editor should be able to say, you're right, you can't share that, and the policy is still in place. On the second part of journal enforcement of open data is difficult or impossible. I agree with that in part. A lot to do a comprehensive review of shared data can be very difficult to do and exceed most journals' limited resources because they're already strapped on just trying to manage the peer review process. But more than 1,000 journals have implemented open data policies and have a variety of different solutions for how it is they manage adherence to that. And so there are reasonable solutions between an extreme of we're going to check and reproduce every paper based on the data that is shared to we're not going to check anything at all. We're just going to say if you did it, that's fine. So there's a lot of reasonable in between there. And then on the third point on low demand for open data, that's another area where I partly agree with the points and then partly disagree. From my perspective, the goal of transparency and sharing is not because there is an enormous amount of pent-up demand to reanalyze data sets from people that share it. It's more the goal of providing transparency so that the self-corrective processes of science can work as efficiently as possible. In many cases, the data will never be touched, but I know that as an author, because my data, my code, my materials could be examined by others, that might change my own approach to how it is I do my research, so that I recognize that I need to be able to withstand public scrutiny, not just of the paper, but also of the process in which I conducted that research. And then likewise, for data sets that are particularly valuable, they may extend and provide enhancements for research in the longer term. So those are my major points that I just wanted to make in direct connection with some of the things that were raised by Dr. Lash. Let me switch, if I can, over to my PowerPoint so then I can make some more general remarks about what I see as the rationale for trying to promote a culture of transparency and sharing through policy as one part, the top guidelines, among the other factors of promoting culture change towards open, rigorous, reproducible research. So I have a link to these slides. I can put that link in the chat later if you'd like to get access to them. But really, where we start organizationally is recognition of a potential gap between the values that we have for research as a community and the practices that the structure of science and the daily reward system of science creates in terms of what happens in how science operates. And if there's a gap between our values and ideals for how we think it should operate and how it does operate, our organizational mission is to try to close that gap. And so there's a lot of ways we might characterize what the values of science are. I like to use Robert Merton's norms of science, the sociologist of science who generated these in the 1940s, because they capture, I think, a lot of some of the intuitions people have of the caricature of what science is like compared to other ways of knowing things about the world. And so I'll just summarize those briefly. One of his norms is communality. A scientific claim doesn't become credible because I say, trust me, that's what I found. It becomes credible based on open sharing of the basis of that claim. Here's the methodology that I pursued. Here's the data that I generated. Here's the inference process that I applied to that data in order to arrive at the conclusions that I'm now presenting to you. And then you evaluate the credibility of that based on looking at that evidence, rather than the counter norm of secrecy. No, just trust me, that's what I found, trust me. The second norm is universalism. The research is evaluated based on its own merit, right? It's going through the methodology and the findings itself, the reasoning process that determines whether we say it's credible or not, versus particularism. Oh, that person's famous, oh, they're at a great institution, we should trust it. Third norm of disinterestedness. Researchers are motivated by knowledge and discovery, just trying to figure out how things work, versus the counter norm of self-interestedness. Really what I'm here for is to get all the grants and get all the great publications and get ahead of the people around me. And then a fourth norm from Merton is organized skepticism. Researchers consider all new evidence, even against their prior work, versus organized dogmatism. I get my dissertation findings and then I spend the rest of my career defending them against all of the attackers in the community. And while Merton didn't talk about it, a common additional norm is a norm of quality versus a norm of quantity. Now, when we look at these, we might recognize them as a very general description of how science is characterized. But an obvious question is, do researchers themselves endorse the norms, or do they actually think science should operate by the counter norms? And Anderson and her colleagues asked 33 NIH awardees, early career or postdocs, mid-career here are researchers in their first major award, so average age around 40. And they just asked, which do you endorse, the norm or the counter norm, going down through that list? And what you see in gray are the proportion of respondents that tended to favor the norms over the counter norms, about 90% of the sample. And in black are those that favored the counter norms over the norms. Very few people said science should operate by secrecy and dogmatism, et cetera. And then the gray hatches are people who said, well, each of these are ways in which science should operate, both. So then they said, okay, don't tell me what you endorse. Tell me how you behave in your research. And the responses look like this. Still 60% or so of respondents are saying that they behave according to the norms over the counter norms. But you can see an increasing proportion of respondents are saying that those counter norms have some weight on their behavior, but still very, very few are saying they behave according to the counter norms over the norms. So then I said, okay, that's fine, that's fine. Don't tell me what you do. Tell me what the people in your community, what do they do? And the responses look like this. This itself, the top versus the bottom, is an operational definition of a dysfunctional research culture. We all collectively endorse these general norms of science, all in quotes. We try to live by those, not completely, and we don't perceive the others in our own subculture to be doing the behaviors according to the norms, but rather the counter norms. And this creates a difficult situation for any individual researcher to decide, how do I behave in this culture? I came into science because of the ideals that I have, the values that I have for it, but the pressures of being a scientist, of surviving and thriving in science, I perceive as pushing me towards behaviors that I don't think are of value. And so I have to make a decision. Either I can have a career by giving up my values and playing the game as I'm supposed to, or I can live and do science by the values that I think I should at the perceived cost of not doing what is normative in the field. So there are many things that we might talk about that are the basis of people perceiving a gap between the values that we have for science and how the culture of science works. For us, it boils down to a critical key piece, which is the incentives for my success are focused on me getting it published, not on me getting it right. Of course, I want to get it right. I got into science to discover things, not to write papers. But the paper as a reward system is a powerful reward. And we recognize that it is currency for advancement in getting a job, keeping a job, advancing my career. And we also know that not everything gets published. Finding something new is more likely to get published than repeating something that has been previously claimed. Having neat and tidy results is more likely to get published than things that are exceptions, don't quite fit, parts that aren't quite understood. And finding evidence for your hypotheses or positive findings is more likely to get published than negative results, null findings. So this is an interesting part where the positive, negative results we could narrow to just null hypothesis significance testing. But there's a lot in which confirming hypotheses, seeing things that we want to see, also fits into there. And that might be an area of difference between our perspectives. So I just want to summarize what we understand as the challenge that that core incentive and reward system creates. And this will mirror parts of the previous presentation. Because I'm incentivized to find novel, positive, tidy outcomes, it's no surprise that there is selective reporting. Findings that don't quite fit the reward, I'm not likely to get them published. I'm more likely to rationalize that I shouldn't even put them in the paper in the first place. Or the reviewers might even say, that's not very interesting. People have done that before, get it out of the paper. Because of the pressures to get certain kinds of outcomes, we have more pressure to do questionable research practices, p-hacking being one example. But anything that increases the likelihood of publication, because publication is partly based on the outcomes rather than just the process of doing the research, will lead to less credible findings. There isn't any direct reward for me to share my data, to show you my materials. It's really just about writing a compelling paper. And yeah, it'd be nice if you saw all those other things, but that's extra work and it's not in my reward system. So why would I spend the time doing it? And replication is not novel. So I'm not going to pursue trying to replicate your findings. And I'm certainly not going to try to replicate my own, because all I can do is lose the finding. Once I have something that is a publishable unit, it's a novel, interesting thing that a journal is likely to be responsive to, I'm less likely to do additional research that could challenge the confidence that we have in it, because I've found that nugget of publishability. So those factors together then conspire to reduce the credibility of the published literature, and even more importantly, eliminate some of the natural processes of self-correction. that are the engine of discovery. We understand that we're going to make error in science all the time. Science is hard. We're going to have lots of things that don't work out, lots of leads that seem promising and then didn't end up promising. That's normal in science. We shouldn't be ashamed or try not to have that. Because if we did, like some of the examples that Dr. Lash showed, we would get extremely conservative in how it is we did our science. We should be pushing the boundaries. But if we don't have a self-corrective processes in place, we don't have the ability for you to reanalyze my data to see if it's robust to different analytic decisions than the ones I selected. We don't have rewards for conducting replication to increase confidence and decrease the uncertainty in particular estimates, then we won't get the self-corrective processes in place so that we more quickly get to reliable knowledge. And so all of that then may lead to more waste, slower progress, poor return on investment. So that's a conceptual description of what we see as a challenge. There's lots of interesting research we can talk about each of the parts of this. But I also just want to position the role of journals as being just one part of the broader system. Journals can set policies about how it is they make decisions about what gets published and what doesn't. But if we don't have alignment between what publishers are doing and how funders are making decisions about grants, how institutions are making decisions about who gets hired and who gets promoted, and how societies work on how to set norms and provide standards, we won't shift the system toward greater reproducibility because all of those play a role in the overall system influencing any individual scientist. So let me briefly then talk about the top guidelines as a concept, in a framework for trying to align these various communities and stakeholders toward standards for trying to promote transparency and sharing. The top guidelines is a set of 8 standards, and each of those standards has different levels of potential implementation that a journal or a funder or an institution could implement. So for example, the data transparency standard, going to level 1 in top, would be requiring disclosure. Authors are not required to share data. They're required to say if data is shared or not. And so they have to put a data availability statement to indicate where, if the data are available, where are they available? Or if they're not available, saying so, and they can explain why, right? This is private data. We can't possibly share it because of X, Y, and Z. A level 2 is requiring data sharing into a repository so that it provides preservation, but that does not disallow the exceptions, right? There are lots of reasons that some data can't be shared. Those are incorporated directly into the policy by having editors have discretion to say whether or not that reason for not sharing is acceptable for the journal's point of view. And then the third level is a verification step. Data must be posted and the journal will check whether the findings can be reproduced by the data that was shared. This is a very high aspirational aim for journals because of the potential burden. But what's fascinating is there are some fields that have adopted this level of data transparency. So for example, most of the leading journals in economics now require this. The authors have to submit their code and data, and it has to be reproducible by a data editor who, for every single paper that they publish before the paper will go into print. Not every journal will be able to meet that because that is a burdensome effort, and they've just made that commitment because they've decided that's important to them. So the summary of the guidelines is the standards that are intended to be agnostic to discipline so that any kind of community could adopt those standards. And in fact, it's even agnostic to quantitative versus qualitative research. So each community can adopt the standards and define, for example, what does data mean in the context of a qualitative study or the kinds of research that we publish, and then adopt the standards that are appropriate for that context. Another important feature is that they are modular. Different research communities are in different places in terms of the relevance of each of those standards to the kind of work that they do or preparedness of their community to think, is this a good thing for our community to adopt or not? And so the modularity is intended to embrace the variation that occurs across communities. So for example, in earth science, You mentioned pre-registration, and most earth scientists said, I've never even heard of that. What is it? So a journal is very unlikely to require disclosure of pre-registration in earth sciences because it's just a completely foreign concept. They don't have the experience of being a neighbor to, for example, clinical trials to at least even know what it is, let alone whether it's something that the journal would want to adopt as a standard. And then the design of the 3 levels is intended to provide a low barrier to entry. That base level for almost all of the standards is simply a disclosure requirement. We don't require you, author, to do anything. We just require you to say whether you did the thing or not. And that's intention to start to stimulate engagement with these issues within communities and provide an occasion for conducting more evaluation of what is the impact of these. For example, the question of whether data gets reused. By providing it as a disclosure, provides an entry point for the community to experiment a little bit. What is it that people are doing? Are they actually reusing these data? Is it worthwhile for us to think about a more intensive requirement? If we make it a requirement, what's the added burden on authors? Is that burden worth it versus the cost of having to prepare the data for sharing when I am able to share it? All of those factors require some experience with the policies, and journals have policies now. And so a systematic evaluation process that comes along with implementation of policies allows for tuning them to be most appropriate for that disciplinary circumstance. So just to highlight back to those challenges that I opened with, these various practices are intended to address some of the key challenges that occur in the current system of incentives. So pre-registration, for example, can address both selective reporting so that all studies are discoverable even if they don't end up in the paper. It can address questionable research practices by making very clear what was planned in advance. These were the outcomes I had planned to examine. Paper, oh, I reported different outcomes. I should be clear and explicit why I changed those outcomes and provide the justification for why I thought that change was needed. And then on the data and materials side, I need to make it easy for you to be able to evaluate the basis of the claims that I made. If you look at the data and say, wow, there's 4 other variables that are actually better indicators of your conceptual variable of interest, why didn't you use any of those? And then you could re-examine them to see if the findings are robust to those. And likewise, sharing the materials lowers the barrier to actually understanding precisely what was done in the research and conducting replications if that is addressed. One of the key, just to close so we have time for the discussion, one of the key interventions that we promote across various journals is the model of registered reports. And this is intended to go after that real central incentive challenge, which is that a lot of the review process is based on evaluating the outcomes of the research as a basis for publication acceptance or rejection. Registered reports changes that model by having the initial submission to the journal be the research question, the introduction, the motivation behind the question, and then the proposed methodology. Here is what we're going to do, here is the planned analysis that we're going to have, and that we will report once we've done it. Then the reviewers evaluate that based on, is the question important, and is the methodology an effective test of that question? And if it passes peer review there, then the journal makes an in-principle commitment to publish it regardless of outcome, as long as the authors conduct what they said they were going to do and then provide a responsible interpretation of those findings. The potential value of that is that it directly addresses some of the key challenges of the incentives being based on results. Because now in that review process, the results are not part of decisions about whether to publish or not. It is exclusively focused on the importance of the questions and the quality of the methodology to test those questions. And then the results are the results. So that ought to eliminate publication bias and many of those other factors, regardless of what statistical methodology is used, no hypothesis significance testing or anything else. And instead focus on how is it that we can encourage researchers to focus on the most rigorous research and most important research possible. And just to highlight that there is a lot of research data, research evaluation on these various practices in progress, in contemporary, as these things are experimented on in different journals, there is a meta-science community that's evaluating what happens with them. So for example, with registered reports, this example, Sheil and her colleagues identified 71 registered reports and then had a selection process of papers that were similar from similar journals published similar times, and just evaluated the first hypothesis that they came to in the paper and said, was that hypothesis supported or not? What you can see is in standard reports, almost all the time, our hypotheses are supported. We're always right about our research. And this is the running joke about published research literature. If we're right all the time, why do we bother doing the research in the first place? We can just do our hypothesizing. We'll know that we're going to be right. Look, we are 95% of the time. With registered reports, where I've made the commitment in advance, this is what hypothesis I'm testing, and this is how I'm going to evaluate whether it's supported or not, the likelihood of being supported falls below 50%. And this is itself showing that registered reports can mitigate publication bias. Those papers still get published, even though it reveals that the author's original expectations were not supported. Likewise, we put registered reports and articles from the same journal on the same topics or from the same authors on similar topics through a peer review process again. And it was a structured review where the reviewers had to evaluate on a variety of different dimensions, the papers as they read them, the registered report or the standard articles. And what we observed in this initial analysis of registered reports and comparison articles is that on every dimension that we examined, the rigor of the methods, how much will be learned, questions and methods alignment, the rigor of the analysis, the quality of the results section, discussion, how much the abstract and the findings are aligned. Across all these dimensions, the estimate for registered reports was more positive than for the comparison articles. These are credible intervals, Bayesian credible intervals, just for information, with the big dot there being the point estimate that was observed across these. So that's enough, I think, for prompting the whatever Q&A discussion we might have on these issues. I have links here if you want to follow up on any of the information that I shared, and particularly with these slides. So thanks again for the invitation, and to Dr. Lash for stimulating an excellent discussion.
Thank you, Dr. Nosek and Dr. Lash. I was wondering if Dr. Lash had any immediate reaction to Dr. Nosek's presentation before we go into questions.
Sure, just a few things. I agree with Dr. Nosek that there's a lot of overlap and agreement. I think that some things that have been maybe left out is the idea of replication. In my view, replication is most useful when there's replication in advance. So when a paper is published and it's susceptible to an uncontrolled confounder or some selection bias or some mismeasurement, ideally the next paper improves on that by addressing one of the limitations of the earlier paper. And I call that replication advanced, and I've written a commentary on that in Pediatric and Perinatal Epidemiology. So, I think that's a concept that we haven't really touched on, but I think is probably important in the literature. Dr. Nosek mentioned that there, in the bottom right of one of his flow charts, there's no self-corrective process. That has not been my lived experience. I guess I've worked in some pretty contentious breast cancer treatment areas where there have been very heated back and forth between investigator groups trying to be persuasive about their view on the topic or the other. That's maybe a talk for another time. And last, this question, I think that the publication bias is a really interesting problem. And I like the idea of registered reports. I would be very open to trying that in epidemiology. I think that managing the review process is the main barrier to that. And one of the main advantages of it is the idea of more often seeing null findings published in the literature, which the dichotomized graph did show. We have published in epidemiology a very clear statement of what we are looking for in null results. It's called seeking persuasively null results. And we've clearly laid out both that we want these papers and what it is that we're looking for as we get a chance to review them. And the last thing, just with regard to the way epidemiology has been managed, even before we became engaged in this topic, we undertook a project where we looked at 3 years worth of original research papers submitted to Epidemiology, compared with what was published with what we could find in the specific aims of the grants that were listed as support. And we actually found very good agreement between, it was at 2/3 to 3/4 of the papers, depending on the subset that you might look at, where what was published was what was planned, what was hypothesized, and the methods were what was described in the grant. I spent the better part of Friday afternoon for an entire summer going through these specific aims. They're not easy to chase down, but that gave us some confidence that we were not just publishing chance findings or things that people hadn't planned to do, that in fact there was the authors, at least what we were publishing, good correspondence between what they had planned and what they were publishing in our journal. So those are just a few things that occurred to me as I was listening to Dr. Nosek's presentation. I think he started with the question of whether, in my view, null hypothesis significance testing is the only factor or major factor. I think it's hard to know until we try. And to be fair, persuasive, prominent people in epidemiology have been advocating for a change in significance testing culture for 70 years without a whole lot of success, some success, but not a lot. So I think it's the bigger criticism is people seem to like it and they don't want to change that part of the culture. So I'll end there. Thanks for the chance just to respond off the top of my head to some of what we heard. But I do agree that there's quite a lot of overlap in our big picture views.
Okay. Dr. Nosek, anything else before we go into questions?
No, those were great follow-ups. I'll just make one mention of on-registered reports. Well, we have unofficially, I should say, NSF funding an RCT of registered reports at journals, so that we can really start, the data that I showed is all observational data, but we're hoping to recruit we have a very broad group of journals, but additional journals will be welcome who are interested in investigating the extent to which this provides any value in their context, but then also testing more causally its role in relation to rigor and reproducibility. So anyone that's interested in that'd be great.
So maybe a question for you, before I consider signing on our journal if you're interested. But,
I'm ready to sign it up.
It's not uncommon for, what I could envision the first draft of this registered report. It could be 4 or 5 years until the paper's results actually then become available, just because of the nature of epidemiologic research, data collection, analysis. And, that for me, having even a subset of the same reviewers of the original submission with submission after results, that becomes very hard to manage. And that's, always been a concern as we've thought about the practicality of that solution.
Yeah, no, you're exactly right. And so the way that we've designed the RCT is, rather than on original submission, the randomization would occur for opt-in, authors would know beforehand, on a revise and resubmit decision. So for particular cases where the editors ask for additional research, either new analyses or a new experiment, if it's a context where they do lots of experiments. And that would be the point where randomization would occur. For the standard practice in most journals is here are the instructions in the action letter, and the researchers go off and do it and then send back a revision. And that would be baseline control. The registered report condition would be plan your work, send us the plan, we'll review that, and then you follow up with it. So because of exactly what you identify as timeline challenges for even just conducting such a trial, that's how we're constraining it in this particular case.
Thank you.
Thank you. David, I saw you came off mute. Did you have a question?
Yeah, if I could, I guess just kind of a question on a reaction from both of you on this, and then maybe turn it over to Igor for either his question or there are questions coming in, and I'll just encourage folks to continue typing in the questions. But I was interested in a reaction to both of you on, I guess a couple of years ago, an article came out signed by dozens of statisticians about changing the 0.05 value down to 0.005 for statistical significance on that. Can both of you offer kind of some thoughts or reactions to that? And I might be able to guess what they are, but kind of why you think that feeling is kind of still out there, I guess. Maybe start with Tim.
Well, you're never going to get me to sign on to anything that is endorsement of significance testing in any fashion. So that, you know, that's a non-starter. But maybe more deeply, that would certainly would improve the positive predictive value in the graphs that the tables that I showed, right? Because the 14% PPV in the table that I showed emanates primarily from this huge denominator of false positives. So reducing that tenfold, you'll get a much higher positive predictive value. That's just math. For me, working in epidemiology and as an editor of a journal focused on environmental epidemiology, the concern I have that has not really been well articulated in the debate about significance testing is that these error rates come with consequences. If you really think about it as an error rate, some are false positives and some are false negatives. The people who suffer and benefit a false positive are different than the people who suffer a false positive or false negative. And real people get really hurt, or sometimes real industries get really hurt, and there are economic consequences. It's much more difficult and nuanced and has ethics and values behind it in ways that simulating this as rolls of a die or flips of a coin don't map to. And so that's one of the many objections I have to the paradigm of null hypothesis significance testing, is that we have lost sight of the fact that, at least in human subjects research, when you make a mistake, that mistake has consequences, and the consequences are different for different people.
Great. Okay, thank you. Brian, I don't know if you have, Dr. Nosek, any thoughts back on that, or?
Sure.
You know.
Yeah. In fact, I'm an author, one of the 80 or it is of that paper. And in fact, I don't think my chat goes to everyone, but in case it does, there's a link to the paper if you'd like to look. The goal of the paper was pragmatic rather than promotion of null hypothesis significance testing. In fact, it's many, if not most, of the co-authors would like to get rid of NHST entirely and move to Bayesian or estimation approaches. And so the purpose was to say, people use p-values and possibly get rid of them. As Dr. Lash noted, like trying for 70 years telling people you're doing this wrong, and it's not actually changing practice. So it was, in that sense, the motivation generating it was, given that people are using p-values, let's at least get them to recognize that 0.05 is not very good evidence for the positive claim that they want to make. In fact, it's at most suggestive evidence under most ordinary conditions. And in fact, the distributions that Dr. Lash showed illustrated that. And so that is the context in which that suggestion was offered. And the concern of power, of the direct trade-off between false positive and false negative, is a real one, an important one, in terms of how pragmatically any such standard would get implemented. Because another common error in null hypothesis significance testing is the assumption that failure to reject the null hypothesis means accepting the null hypothesis. And it's not. in underpowered situations, you just don't have enough evidence. And so you can't draw a conclusion about whether the null is true versus the alternative hypothesis is true. But of course, that's how we reason dichotomously. And so we do so much with that barrier of 0.05. I think there was, even Dr. Lash's presentation had an example of this, interpreted right across the 0.05 barrier as significant, non-significant, meaning it's there, it's not there, even though the estimates were virtually identical. So that is a real challenge. And so what the paper actually suggests is that it's not that now 0.005 is the demarcation between positive and conclude negative, but rather that 0.05 to 0.005 is suggestive territory. But I will certainly embrace a lot of the concerns as they were articulated by Dr. Lash, that this is sort of a Band-Aid fix on the way that practice occurs now. It is not a comprehensive solution for how it is we can improve statistical practice moving forward.
Great, thanks very much. Igor?
Yes, again, gentlemen, thank you very much for presentations that generated mountains of questions. We will not be able to get through all of them to questions from the audience, let alone my questions, which probably number in a dozen. But let me try to start with some questions from the audience. And one of the attendees wonders whether epijournals have taken a stance on no more p-values, no more hypothesis testing, or whether there are any other journals in other disciplines that have done that. I have banned p-values in my classroom. Nobody gets an A in my class, i.e. gets published, if they mention p-values worth significance at all in their final papers. And that stick works. So I'm just wondering whether, it is within power of editors to do that.
So can I share my screen for just a minute that I have data? Well, it's not working. Are you seeing the screen with the plots?
No, nothing's showing.
But you should be, did you receive the prompt to be a presenter, Tim?
Okay. Let's see. Now? Still not. Okay. Well, in any event, for whatever reason, it's not sharing screen, probably user error. Epidemiology's editorial philosophy for 35 years now has been not to publish dichotomized significance testing. And Andreas Stang studied the major medical journals and the epidemiology journals. It's a paper that was published in the European Journal of Epidemiology in 2016, and that I'd love to show you. Epidemiology, it clearly stands out differently from all other journals. There are downward trends in the prevalence of null hypothesis significance testing, especially in the general interest epidemiology journals, and some downward trends even in JAMA, Lancet, BMJ, New England Journal of Medicine. So it has been slower than I would like, slower than many of us, I guess including Igor would like. I think the uptake of the idea of estimation without significance testing has grown more prominent in the epidemiology journals first. The editors met in October 2019 and were universal in their view that this has to continue to be discarded. But the fact is, until the major medical journals begin to adopt this kind of mindset, Bayesian credible intervals, would love to see that. But even just focus on estimation without significance testing. Until the major medical journals insist on that, there's going to be very little change. So I think that's the main message is the epi journals can do whatever they want. The real power here is held by the clinical journals and the major clinical journals, and they do not seem interested in discarding significance testing. In fact, as recently as a couple of years ago, published the paper saying they weren't going to, even in the face of the American Statistical Association saying you ought to.
Okay, thank you. Brian, would you like to comment on experience in other disciplines?
I'll just give one anecdotal example that I found very interesting. The journal Basic and Applied Social Psychology banned p-values and confidence intervals and prediction intervals and said, we just want you to look at the data and report on it. And that it didn't go very well. There's been some analyses of what happened to the papers once they did this, and the inferential reasoning is all over the map. And I think that experience, to me, others would disagree that were involved in that, but to me, the experience is illustrative of this is hard. People are defaulting to null hypothesis significance testing and reasoning dichotomously because they don't have other great ways to approach how it is we can reason about evidence. And so there is a real crutch aspect to why it is we keep returning to some of these deficient statistical reasoning practices that will require a strong collective effort. Certainly the powers that be play a huge role in that, but a broader collective effort to try to raise people's statistical reasoning practice.
Yeah. Thank you. I mean, I always have an impression that at fault is teaching statistics at all, because the way it's taught. And if I look at some of the papers from the 40s, 50s, they present evidence and analyze it. They don't have any fancy stuff, and a lot of it still makes sense. Has not been, rejected by more sophisticated calculations. Okay, maybe David wants to ask the next question that he can pick from the audience, or
yeah,
go
sure.
ahead, please, David.
I'll go ahead. I'll just kind of go down to the very bottom and ask this question here. We see the registered reports most often in clinical trials, but very rarely in environmental epi. Can the presenter speak to why that may be and how to improve this among the environmental epi field? So registered reports we see in clinical trials, not so much in epi.
I'm not sure if the question is about registered reports in the way that Dr. Nosek meant it, or just pre-registration in a more general sense. Do you have an idea?
I think probably a more general sense, basically, in terms of this and why it's kind of more accepted in clinical trials, but what it would take to improve that in the environmental epi community.
Well, it's required, at least in theory, for clinical trials, that before they can be published, they had to have been registered. In fact, in the US, and I think the European Union, a legal requirement. So that's quite a different space than non-randomized epidemiology. How you could improve it, I guess, would be the ideas that Dr. Nosek has described as continuing to advocate for it. And so I guess maybe I should turn over to you, because this is your space more so than mine.
Yeah, it's an interesting area of culture change, is how do we start to translate practices that have been common in some domains to others? And an obvious question to ask is there a reason beyond the legal requirement, in this case, clinical trials, right, required by law since 2000 to register, and other fields around it have not had that requirement. And the origins of that are an interesting story itself for why it became required by law. But the same kinds of considerations haven't been in many other fields. But there may yet be fit for purpose challenges. How is it that pre-registration can actually be applied in this context? And that's worth evaluating, because maybe chemists don't pre-register because the way in which chemistry works as a field doesn't align well with pre-registration. I haven't yet seen a situation where it doesn't translate completely, but there certainly are adaptations that are needed to some of these concepts. That's one factor. A second factor is just awareness and experience. It's a new behavior, And it's a behavior that moves a lot of what we do earlier in the process. So if we have to document, for example, our methodology and analysis plan in advance, then we have to think it through in a way that we don't ordinarily do it in the other process of doing research, which is sort of interactively with our data. Do we go through our process of decision making about exclusion rules, outliers, data treatments, et cetera. So it takes some time to learn how to do that, how to translate it into the new practice, and to see how that plays out in particular methodologies. So one of the areas that we have found most effective at introducing things like pre-registration to new areas is conducting special issues that are particularly about that at journals, calls for proposals. And so what that allows for is people who are pre-registration curious in a field can have an opportunity. Oh, I've always wanted to try that. Sure, I'll submit something to that special issue. And then the field gets some exposure to it. The review process gets some experience with it. The readers of those articles get to evaluate, did this actually do something of value? So it's really more in the proof of concept phase of let's just try it out as a practice, and then more systematically evaluate, if that goes well, systematically evaluate how that might be introduced and then assessed with broader and broader adoption.
Great. Okay. Thank you, Igor.
In the space of environmental epidemiology, I think that where there would be utility is in topic areas where there is controversy, including controversy about sources of bias and uncertainty, where investigators with the different perspectives, perhaps regulators, industry, came together and said, this is what needs to be done, and wrote a protocol together and agreed that this is going to be a good study that's going to provide substantial and persuasive evidence. That would have real utility, but there's really no mechanism for getting, consistently getting people in a room to that kind of agreement on a protocol. But that, I think that would advance the practice of environmental epidemiology in important ways.
Yeah, that is a great example because it really provides this opportunity of, prior to being influenced by the results, where because I have a point of view, I may be more inclined to some and less inclined to other findings. And if I don't like the findings, I'm sure to find problems with the methodology. Getting people to pre-commit to a shared design and analysis plan at least exposes that motivated reasoning that I bring to the table when the results come in. And there are a couple of examples of this in practice that might translate well into environmental epidemiology. One is the lab at DC, a public policy group in the District of Columbia, did this for body cameras for police officers. So they designed a trial and brought lots of stakeholders in for agreeing on that trial beforehand, so that the results would be taken seriously by everyone. And obviously lots of passions about that. A second example is in the field of consciousness research, where there's lots of theories and every theory is sort of its own island, and the researchers never actually interact with each other's theory. They say, see, I'm always supporting my theory. That must mean your theory is wrong. The Templeton World Charity Foundation brought groups that had presumably competing theories into a room together to design experiments that would predict different outcomes between the theories. And there was all kinds of responses to this. In some cases, the teams got together and fought for 3 days, and out popped an experiment where they eventually agreed this would distinguish it. Other times they got in the room together and fought for a while of telling each other what their theory was, and they just could never come to agreement and of being able to even come up with an experiment that would distinguish them. But just that process itself is interesting and illuminating on where the passions and the reasoning is about the evidence. So yeah, it's a great example for how that might be useful.
Great. I think the next question from the audience may help illuminate some of these discussions of how to bring people together who may have conflicting ideas, viewpoints, practices. And so one of the members of the audience says that they were struck by the mistrust in others that Dr. Nosek showed. And the more detailed question was, were there trends within norms of counter-norm categories where there is more consistent trust or mistrust with how we report behaviors, with how we believe others are behaving, that would suggest that pre-registration could help build more trust within the scientific community. So essentially, are there particular, is pre-registration a solution to some of these tensions that we're seeing? And what evidence may exist to that effect?
Yeah, that's a great question. A lot of the distrust that occurs, not just in science, but more broadly, is distrust in underlying motives and in what the actual practices are that I can't see or you can't see of what I did. And so the transparency of the pre-registration process itself and that pre-commitment, the data are not visible yet. This is what you said beforehand, is a way to replace trust with transparency that has a nice potential side effect, maybe not side effect, direct effect of actually increasing trust in the process. So I may still be suspicious of that person. Oh, I can't possibly trust them because I know what their motives are, I think. But I have much less to question about the process of their research itself, because I can see that they committed in advance, that they wrote all of this down and everything else. And so that may also, besides making me trust the evidence more, it may also have the salutary effect of reducing some of that sniping at each other from afar, making assumptions of negative intent or bad motives, because I just can't see how it is people approached it. Great question. Thank you.
So I think, in non-randomized epidemiologic research, I do not often see these kinds of mistrust circumstances. The differences between investigators or investigator groups tends to rise more from the triumvirate of biases, right? Uncontrolled confounding, poor measurement, selection. And maybe there's ample ground for differences on those topics to explain differences in results, so people don't need to resort to personal, mistrust. But I think, which is why I come back to this idea of replication in advance. Do a better study. That's what I think is most needed in most epidemiology settings. Is this study's positive result could be causal, or it could be due to this uncontrolled confounder. Well, then you have to do a better study that controls for that confounder. No, that is really the only solution. And that is more often the space that I see non-randomized epidemiologic research differences arising.
Yeah, I think we all have some slightly different experiences, but I have observed a great deal of mistrust based on very superficial descriptors that our peers have, and when somebody would become an enemy once they graduate and go take a different career path than another person. So, but I think it's a question that is perhaps worthy of more careful understanding with the help from our colleagues in behavioral sciences, because I've grown concerned that it's not beyond disagreement. I think it seems to me be beyond disagreement in methods. It's more fundamental and not always rational.
Yeah,
okay,
I think I understand where you're speaking from, and I have colleagues in pharmacoepidemiology who work for pharmaceutical industry who are very grateful for the opportunity to pre-register their protocols for the reasons that maybe you're describing, Igor, that it provides some defense against this is just industry-generated research. And I think that's a reasonable motivation on their part for wanting to pre-register a protocol.
Yeah, and have more habit of doing it in that realm anyway. Okay,
exactly.
I'll hand the podium over to David so he can pick his question from the wide selection that we have.
Sure. Okay.
So just one thing, David, before you ask the next question, I want to make sure, because originally we had budgeted an hour and a half. We still have about 30 people, 30 attendees. I just want to make sure that our speakers are, if you are okay answering a few more questions and going over time, then we can do that. But I just want to make sure that you're okay with that and that we're respectful of your time. Tim and Brian.
It's okay.
Okay.
Thanks.
Okay. Thank you.
Okay, great. I'll question kind of relate a little bit to the past one and some of the things that Dr. Lash had commented on. How does the impact of null hypothesis significance testing on the reproducibility of epidemiological research in turn affect non-academic stakeholders, such as policymakers, industry, for example, pharmaceutical versus chemical, and the general public?
So I know people don't like this answer, but when it comes to epidemiologic research, there's no substitute for patience. I mean, you need multiple studies, multiple designs, and that's why I think that our PhD students' project on this Taubes paper was so influential for me. Is that, you know, we don't like to wait, but it takes a while before the epidemiologic research converges to a persuasive body of evidence, and where all of the potential confounding measurement selection biases can be adequately addressed. It just takes time. And so that's not an easy answer, but it is, I think, the fact of it.
Okay.
I agree with that. Just to add a little bit, one of the primary challenges that we have from science translating to public or policy understanding is the recognition and embracing of uncertainty. Policymakers may need to make a decision today. We've seen a lot of that need in policymaking over the last few years. And they should use the best available evidence, but they should use it eyes open to the degree of uncertainty. And instead of trying to hide that uncertainty from the community for saying, oh, well, people just can't wrestle with uncertainty, is use that as part of the process for bringing people along. This is what decision we're making based on the best available evidence and the costs of that evidence being right in this direction, wrong in that direction, or whatever. And we're going to revise the policy as more evidence accumulates. So that's a real challenge of how the scientific community helps to translate that, and then how the actual translation community, journalists that are reporting on this, and public policy officials that are connected to science, how it is they engage those audiences to bring uncertainty into the discussion.
Okay. So just as a really quick follow-on, I mean, other than kind of be patient, basically, any thoughts in terms of how regulators or policymakers are indeed doing on that score, as opposed to not making hasty decisions, for example, but also with the idea that there's the intention to protect public health. Any comments back on some of what's going on?
I have been frustrated during this pandemic by the resistance to Bayes methods in some of the policy making. That would be one thing that I would point out, that, you know, I understand the need for trials, for example, in children under 5 and then 6 to 12-year-olds and so forth. But by the time children less than 5 were authorized for vaccination, literally billions of vaccine doses had been administered across the planet. And kids 0 to 5 are not just little adults, but they're not little adults also. Right? We could have borrowed a little information from the vaccine trials and the experiences of billions of people and potentially gotten those out earlier. So I think, to my view, if I were to say where I would like to see Bayes methods incorporated more rigorously and routinely in policymaking, that would be my, if I could wave a wand, that's the wand I'd wave. And I agree with Dr. Nosek about the uncertainty. As you know, some of you know, I've written a lot about quantifying not just random error, but other sources of error.
Dr. Nosek, any thoughts back on that?
No, I agree.
Let me jump in and let me make first of all a selfish comment, and sort of give another vote for Bayesian things, and to express my personal view that it would be helpful to know not only posterior distributions but the priors and to what extent they were updated. I've seen some beautiful, very effective, intuitive graphical presentation of this recently through my collaborations. And that issue of mistrust may be mitigated if we actually know where people begin. But I have been told that we at X, very prominent, powerful body, cannot do Bayesian methods. And I was told that openly at a public forum. So I think we have some work to convince folks still. But now I'd like to go to members of the audience. One of the questions is that while promoting transparency and openness seems desirable, for environmental chemical toxicity, it has been proposed that results obtained in the past should not be used unless those data and analysis methods are now made public. Moving forward versus retrospective application seems to be a major issue to be addressed. I would like to know your thoughts on these matters. I don't want, who wants to go first?
So
gentlemen.
The premise is that toxicology data from days gone by generated in Little Rock should not be used unless the data are publicly available. I mean, I maybe not surprisingly, I don't think that's a good idea. I think, you know,
what about epidata that is from days long gone by where sharing it is not an option, cannot be disclosed? Data from 70s, 60s. I mean, should we just throw it out and not use in regulation unless it's open?
I mean, the only place where I have felt like discarding evidence made sense is where we knew it was collected unethically. And those situations are limited. Otherwise, I think it ought to be incorporated in some fashion at least.
Thank you.
Yeah, this is a great question because it hits on what has happened and will continue to happen on the weaponization of transparency and openness for political ends. So, for example, there have been movements in our federal administration, US, on EPA requirements that you must have open data for that, for this particular, to inform regulatory policy. And of course, there are some EPA, some data sets that are very relevant for policy that can't be shared for some of the reasons that were articulated during the earlier session, privacy data and otherwise. And so this is not going to just go away because there are strategic reasons that people with points of view may deploy transparency as a bludgeon when it is useful for other ends. And so that's a real challenge for the openness movement to be ahead of at all times because that occurs. I was invited to give testimony on this issue to a House committee. And again, I don't know if my things in the chat go to everybody, but I can provide a link to the testimony if you want to see it. But
it does, and yeah, we can also share material with everyone.
Okay, yeah, that's great. So it's just it's an issue that comes up again and again. And in this particular context, some of the congressional representatives say, shouldn't we have transparency for data that informs EPA policy? Like, isn't that what your whole organization is about? And I say, well, yeah, we want to promote transparency, but we also want to recognize that not everything can be transparent, and rulemaking should be based on the best available evidence, not just only on the evidence that meets some purity standard that we can construct, because not all evidence is going to meet such a purity standard. So it is a real interesting challenge to navigate this in a political environment when scientists really just say, we just want to get the best evidence we can.
Okay, thank you. Over to you, David.
Yeah, sure. Great. Thank you. It almost sounds like there's more agreement between you two than disagreement on it, just overall on this stuff. Two kind of questions.
Sorry to disappoint, by the way.
Okay. No, this is good. This is great. So two questions, I guess very quick questions by the same person. I wonder if any epi journals have taken the stance of no more p-values or hypothesis testing on that. I believe Epidemiology has. Tim Lash, are there others? And the second part would be statistical significance is your reaction to this, basically. Statistical significance is a kind of indicator of the strength of an association, how to present this without calculating the p-value. So epi journals taking the stance, and then statistical significance is kind of an indication of the strength, which you might have reactions to.
So yes, I mean, it's always been the editorial philosophy at Epidemiology that we don't publish dichotomization of results as statistically significant or not. We also have no illusion about the fact that authors may have chosen to submit to us after having conducted a statistical significance test and just not labeled it that way. You know, we have published on, we similarly have very high proportions, as Dr. Nosek showed, of results that would have been characterized as statistically significant. It's not quite as high as other journals, but it's still higher than you would expect by chance, I think. So there's no question that there's some selection, even if the labels aren't being applied. I do not agree that it is a marker of strength of association. I mean, it's conflated between, it's delta over square root of V, right? That's what it is. And if you're interested in delta, then you don't want to conflate it with square root of the variance. And so you want those two things to be kept separate. And so you can have statistically significant results that arise from just outstanding huge data size, and so very small V. And you can have results that are very large, important strength of association, but also large V that you might not take note of. So it's not a very good screen if you're interested in strength of association.
Yeah, great. Yeah, tiny studies will not have significant p-values. Huge studies will on that. So great. Dr. Nosek, do you have any thoughts back on that? Agreement, disagreement, or?
Just the only thing to add, I agree with all the point there. If we're trying to distinguish strength of association versus strength of evidence, there might be a way to argue for strength of evidence being associated with the size of a p-value. In the narrow sense of likelihood to replicate. And this again just goes right out from the distributions that were in Dr. Lash's presentation, that the more extreme that p-value, the more likely it is that a subsequent study that's properly powered could reject the null hypothesis in the same way, even with some shrinkage based on publication bias and everything else.
Quite right in all regards, but still assigns a primacy to the null hypothesis that is often not merited, right? What Sandra Greenland's been calling nullism, you know, this over attention to the null hypothesis. So it's really the p-value does equate to that when the null hypothesis is the test hypothesis, and the p-value is calculated under the assumption that that null hypothesis is true. Then I agree with what you've said. But none of that has to be. It's just the way it is.
All right. Well, we still have some members of the audience going strong, but I think we want to be respectful of everybody's time. So maybe last round of questions or comments from me and David, and then we can thank you, gentlemen, and wrap up. I was very much intrigued by evidence. This is a question from me, sorry, I'll exercise that prerogative. That registration seems to be somehow related to quality of work being published. And I was wondering whether that is related to the type of people who are willing to pre-register their work rather than active registration. And, you know, in some journals, especially one that I've been involved in on methodological work, they explicitly instruct us not to accept paper based on its perceived importance and only judge methods. And there is no pre-registration at all. So it's just, is it the people or is it the act of pre-registration?
Excellent question. So in the observational study evidence that I showed that you're referring to, the control papers are, half of them are from other authors on the same topic in the same journal, so trying to hold journal standards constant. And the other half of the control papers are the same authors, at least same first or last author on similar topics. But nevertheless, that does not rule out the possibility that it's a sample difference of who is doing this practice. So even if those are good comparisons, these are folks that have decided to do registered reports as this new thing. These are some of the very first registered reports that have been published. So it could be a very different sample than what this model would look like when brought to scale across a variety of different people. So we can't really say anything with confidence yet about how the value of pre-registration or not may interact with the type of research and the type of researcher that conducts it. So it's a great question. Thank you.
Great. Okay, so I'll ask the last question, one for each of you on that, and then turn it over to Sandrine to close out. One of the questions is basically inquiring minds want to know what is that fascinating map on Dr. Nosek's back wall?
So that is the Atlantic coastline from Newfoundland on that end down to Alabama and Florida on this end, turn sideways, and it's the plate tectonics. So it's a geological survey from the 1960s, I think, and I just loved it visually, so got it framed and put on the wall. So thanks.
Okay, great. And then the other last question, I guess, for Dr. Lash. You mentioned your second edition out. I'm a great fan of your first edition for quantitative bias analysis. Thoughts on when the second edition may actually be out, or ideas?
It's out.
It is. Oh, okay. As of about 3 weeks ago, I didn't think it was. So great. Is that just like last month or so?
There's the second edition, and there's the first edition. So you can see there's some value added.
Yeah. Yes. Okay. So worth the purchase on that. Great. So okay. Turn it over to Sandrine then, if you want to close this out. And I'll just say for myself, thank you very much to both of you. This has been kind of a wonderful conversation on that.
Yes, thank you. It's fantastic. Thank you very much, both.
No audio, Sandrine.
Okay. Oh, maybe it'll be up to me and Igor then. You're not. Maybe you're.
Is it working now?
It's working now. It's working now.
I was double muted. That's the problem with headset. So just wanted to reiterate a big thank you to our speakers, and thank you for being generous with your time. I know we are aware of a budget in terms of time here. We still have about 30 people on the line, so people have been hanging on. Which was two fantastic talks, very engaging conversations. So I really appreciate your participating in this. The recording of the webinar should be online in a few days, probably before the end of the week. Brian, Tim, if you have any material papers that you would like to share with our audience, that's something that we can do in the follow-up email. We can share some materials, so feel free to send me anything that you would like to share with the audience. In terms of future webinars, we're going to take a little break over the summer, but we're planning a PFAS expert panel for early fall, so probably September, October. And then just so you know, so previous webinars that were held earlier this year and last year are available on our website. And we're always happy to receive some feedback, some questions. If anyone would like to propose speakers or themes that we should cover in these webinars, we are always happy to hear from you. So feel free to contact me, send me an email. So with that, again, a big thank you, and we're going to adjourn.
Okay, thanks
very
Thank
much.
you.
Thanks very much. Be
Bye.
well.
Bye.